Hello, welcome to another module in this massive open online course on probability and random variables for wireless communication. So, we have started looking at random variables, that is random variables which can take values randomly on the real line or from a subset of the real line, alright, and we have defined the probability density function to characterize the behavior of these random variables, to characterize the probability of these random, or the probability density rather of these random variables. Today let us start looking at two other important parameters that are associated with any random variable, that is the mean and the variance. So, in today's lecture we will look at the mean and variance of random variables, or the mean and variance of a random variable. And the mean, as you must already be familiar, the mean is basically the mean. Let us say I have a random variable x, this is my random variable, this is my random variable which is characterized by the probability density function f of x of x. So, this is the corresponding PDF, that is basically our probability the PDF for the probability. So, we are considering a random variable capital X which is characterized by the PDF f sub capital X of x, that is the probability density function of this random variable x. Let us now define the mean of this random variable x, and the mean of this random variable, that is defined as the mean of this random variable, the mean, as we know, the mean which is basically the average value of the random variable x, which is denoted by mu, which is also denoted by the notation E. It is denoted by the notation E of x. This basically stands for the expected value of the random variable x. So, this stands for the expected value of x. So, E of x basically stands for the expected value of the random variable x, and this is defined as, this quantity, the mean or the expected value of x is defined as minus infinity to infinity x times f of x dx. This is the definition, that is integral minus infinity to infinity x times f of x, where f of x is the probability density function, dx, that is the integral from minus infinity to infinity x f of x dx. And let us look at what this means intuitively. What this means intuitively is the following thing. Let us look at, go back to our schematic of the probability density function. This is our probability density function. Now, let us look at a small interval around x, small interval of length dx around x, that is between x and x plus dx. This is the infinitesimally small interval around x. Now, the probability that x takes a value in this interval, that the probability x lies in this interval is, as we have seen before, f of x dx. Okay. So, the probability the random variable x lies in this infinitesimally small interval of length dx around small x, that is it lies in the interval x to x plus dx, is f of x times dx, where f of x is the probability density function. Now, we take the probability that it lies in this interval and multiply it by the value x. So, it takes the value small x with the probability f of x dx. Therefore, the mean, the average is basically the weighted average of all these values, that is the integral x f of x dx from minus infinity to infinity. So, we are saying with probability. So, it takes value of value x and the corresponding probability is f of x x dx. Therefore, the average, the mean is basically minus infinity to infinity x, that is a value weighted by the probability f of x times dx. So, this is the value x which is weighted by the corresponding probability. This is the corresponding probability, this is the probability this is the probability that x takes the value of x. So, what I am doing? I am taking the value small x, multiplying it by the corresponding probability f of x dx, and I am integrating it from the between the limits minus infinity to infinity. So, I am weighing the values by the corresponding probability, and that gives me the average value, that is the average value that is taken by this random variable corresponding to the probability density function f of x. Okay. So, that is the definition of the mean of the random variable x, or the expected, which is also denoted by, we said E of x, that is the expected value of this random variable x. Let us now look at another interesting statistic. Let us look at the variance of a random variable. Let us now look at the variance of the random variable. Variance of x is basically the average of the square deviation about the mean mu. So, the variance is basically, this is the average of the square of the deviation about the mean mu. The variance is denoted by sigma x square. This is the variance of random variable x, this is the variance of our random variable x, and that is given as the expected value or the average value of x minus mu whole square. Remember, mu equals the mean, remember mu is the mean, x minus mu is the deviation about the mean, x minus mu square is the square of the deviation about the mean, and we are taking the average of this square of the deviation about the mean. So, as we said, I have to take it for every point small x, and I have to weight the corresponding probability f of x dx. So, the average of the square of the deviation is nothing but basically again integral minus infinity to infinity x minus mu whole square times f of x x dx. So, this is the average. Basically, what we are doing is we are looking at the square of the deviation, we are looking at the square of the deviation at any point x, and we are weighing it with the corresponding probability, and this is the corresponding probability x takes value x, that is a corresponding probability that x takes the value small x, that is it lies in the interval x to x plus dx is f of x dx. I am weighing it by the square of the deviation x minus mu square, integrating from minus infinity to infinity, that gives me the average square of the deviation of this random variable. Let us now simplify this expression further. Now, if I simplify this expression further, I will have sigma x square equals minus infinity to infinity x minus mu square f of x of x dx, which is basically now if I expand x minus mu square, that is x square plus mu square minus 2 mu x f of x x dx, which is therefore equal to minus infinity to infinity x square f of x x dx plus mu square, mu is a constant, so it comes out of the integral minus infinity to infinity f of x x dx minus 2 mu integral minus infinity to infinity x f of x dx. Now, if you look at these two quantities, for instance, if you look at these quantities, integral minus infinity to infinity f of x dx, that is equal to 1. We are saying integral minus infinity to infinity of f of x dx is 1, because that is the total probability, and that is the from the basic definition, from the basic property of the probability density function that we have looked at in the previous modules. Further, as per our previous definition, integral minus infinity to infinity x times f of x x dx, this is nothing but the mean mu of the random variable. Therefore, substituting both these, what we have is basically we have sigma x square, the variance equals minus infinity to infinity x square f of x x dx plus mu square times 1 minus 2 mu times mu. Now, look at this, I have mu square times 1, which is mu square, minus 2 mu times mu, which is 2 mu square. Therefore, mu square minus 2 mu square, which is minus mu square. Therefore, this reduces to minus infinity to infinity x square f of x dx minus mu square, which is basically the same as the expected value of, now look at this quantity. This quantity is the average value of the square of the random variable. So, this quantity is expected value of x square minus mu square, and therefore, what we have is something very interesting. We have the variance of the random variable equals the expected value of the square or the average value of the square of the random variable minus the square of the mean. This is also written as e to the power of x square minus e of x whole square, that is the variance equals average, the variance equals average of x square minus the square of the average or the square of the mean. So, the variance of this random variable, sigma x square is the expected value of x square minus expected value of x whole square, that is expected value of x square minus mu square, where mu is the mean of the random. So, the variance is basically the average value of the square of the random variable minus the square of the average value of the random variable. This is the definition of the variance. So, what we have done so far is, if you look at this, basically we have started with the random variable x, the probability density function f of x, and basically we have defined the mean of this random variable. The mean of this random variable is the average value, which is basically integral minus infinity to infinity x times f of x dx, and we have also looked at the standard deviation of the random variable. We have said that the standard deviation of the random variable is basically the average value of the square of the deviation of the random variable about the mean, and we said this is denoted by sigma x square, the variance, which is equal to basically the expected value of x square, the average value of the square of the random variable, minus mu square, where mu is the mean of the random variable. Alright. So, these are two important parameters for the random variable x. We will stop this module here and look at applications of these in the subsequent modules. Thank you very much.